In this video, we'll discuss arrays principle. We will see the second question. This is valid anagram. So first of all, valid anagram. So what is this question about? Given two strings s and t, return true if t is an anagram of s and false otherwise. For example, s is anagram, t is nagaram, and like output is true. Why? Because whatever, like suppose in s, so we'll explain this later. So like this is true, and suppose we have rat, s is rat and t is car, then it is false. Okay, so like we'll explain it now. I will try to explain the problem. What is the problem statement? You are given two strings s and t. Now you must determine whether t is an anagram of s. Return true when both strings contain exactly the same characters with exactly same frequencies. This is what it is. This is when we have to return true, otherwise we will return false. Okay, so first of all, what is an anagram? Two strings are anagrams when they contain the same characters. Every character appears the same number of times. The order of characters can be different, but the goal is that every character must appear the same number of times. For example, s is equal to anagram, t is equal to NAGARAM. Both strings contain a is equal to 3 times, n is equal to 1 time, g is equal to 1 time, r is equal to 1 time, m is equal to 1 time. The order is different, but the characters and their frequencies are identical. Therefore, NAGARAM is an anagram of anagram. This is what it is. Example 1. Input s is equal to anagram, t is equal to NAGARAM. Output is true. Explanation. Character frequencies in both strings are a is 3 times, frequency in s is 3 times, frequency in t 3 times, n 11, g 11, r 11, m 11. So the frequencies of all these characters in both the strings are same. Therefore all the character counts match. Therefore true. Example 2. Input is s is rat, t is car. So therefore here we have r, but here we don't have an r. So therefore the output is false. I hope this is well understood. Now the explanation for this is as follows. Character frequencies are different. For s is equal to rat, r is equal to 1, a is equal to 1, t is equal to 1. For t is equal to car, c is 1, a is 1 and r is 1. So the first string contains t while the second contains c. Therefore the strings are not anagram. I hope this is well understood. Now important condition for two strings to be anagram. Two strings can be anagrams only when both of the following conditions are satisfied. Number 1, their lengths must be equal. For example, s is equal to cat, t is equal to cats. Their lengths are its length is 3, its length is 4. Therefore they cannot be same. They cannot be anagram because one string contains more characters than the other. Condition 2, every character frequency must match. For example, s is equal to AAB, t is equal to ABB. Both strings have length 3 but their character frequencies are different. For s, a is equal to 2, b is equal to 1. For t, a is equal to 1, b is equal to 2. Therefore equal length alone is not sufficient. This is very important, right? I hope we have understood till here. Now let's go further. Strings. String is a sequence of characters. For example, s is equal to anagram. The characters can be accessed using indices 0, 1, 2, 3, 4, 5, 6. Index 0 is a, index 1 is n, 2 is a, 3 is g, 4 is r, 5 is a and 6 is m. Therefore s of 0 is a, s of 1 is equal to n, s of 2 is equal to a. I hope this is understood. In Python, Python's length function returns the number of characters in a string. For example, length of rat returns 3. The code first checks if length of s is not equal to length of t, return false. Because for two strings to be anagram, first of all their lengths have to be the same. Next, dictionary or a hash map. A dictionary stores information as key value pairs. For this problem, we store character frequency. For example, count s. Then we are actually trying to calculate the frequency of all the characters. So like we have a is equal to 3, n is equal to 1, and g 1. Like a appears 3 times, n 1 times, g 1 times, r 1 times, and m 1 times. This means a appears 3 times, n appears 1, g appears 1, r appears once, and m appears 1. We have already seen this thing. Now character frequency. Frequency means the number of times a character appears. For example, A, B, B, C. The frequencies are A appears 2 times, B appears 2 times, and C appears 1 time. If another string has exactly these same frequency, it is an anagram of S. So for two strings to be anagrams of each other, one very important thing is like the length of both the strings should be same, and after that the frequencies of each letter in both the strings should also be the same. Okay. And now we'll discuss something which is very important, that is like get method in dictionary. The code uses count s dot get s of I comma 0. What does this mean? The general format is dictionary dot get key dot default value. It means return the value associated with the key. If the key does not exist, then return the default value. For example, count s is equal to a 2 times. Therefore, count s dot get a comma 0 will return 2 because a is 2 times. That's why, because a exists, but count dot get b comma 0 will give 0. So what it means is, in count, suppose this is count is a dictionary which says a appears 2 times. Then suppose if you want to this here, you are trying to get a. If you are trying to get a, you will get the count of a, that is a's count is 2. Now suppose you are trying to from this count s only has a, it does not have b. Now you are trying to get b here. Since you are trying to get b here and it does not exist, it returns the default value. What is the default value? It is 0, so it returns 0. So because b does not yet exist, it is useful when counting characters. So I hope this is understood. Now we will see the thing. Okay, the code uses two dictionaries, count s and count t. This it counts all the characters in s and it counts all the characters in t. They store the character frequencies of s and t. The process is check whether the string lengths are equal, create two empty dictionaries, count every character in s, count every character in t, compare the frequencies of every character, return false if frequency is different, return true if all the frequencies match. So this is what the algorithm is. Now we will see the complete code and then we'll type it in the real code. So it's like, as we have seen, if length of s is not equal to length of t, return false. Okay, now we have initialized two dictionaries, count s and count t. Now if suppose the lengths are not the same, it will return false. Now suppose if the lengths are same, then what we'll do, for I in range length of s, count s of I is equal to 1 plus count s dot get s of I comma 0. Means we are trying to get all frequencies of all the characters in s. Here we are trying to get frequencies of all the characters in t. Count t of I is equal to 1 plus count t dot get t of I comma 0. If count s of c, now for c in count s, if count s of c is not equal to count t dot get c comma 0, return false, else return 2. Now I will explain what this code actually means. Okay, we can start from here. See, if length of s is not equal to length of t, return false. It checks whether the strings have different lengths. This is very important. I hope this is understood. Simple, not this means not equal to. For example, rat and rats. Then length of s is rat and length of t is 4. Therefore, the condition becomes if 3 is not equal to 4, which is true, right? Therefore, the function immediately returns false. Strings with different lengths cannot be anagrams. So number 1. Next, what we are doing, we have count s and count t. This creates two empty dictionaries. It is equivalent to writing count s is equal to this and count t equal to. Their purposes are, count s stores character frequencies from s and stores character frequencies from t. Now initially count s and count t will look like this. I hope this is well understood. Now looping through the string. For I in range length of s, the loop goes through all the valid indices of s. Suppose s is equal to rat, then length of s is equal to 3. Therefore, range of length of s becomes range of 3. The values of I are 0, 1, 2. Because s and t have same length, the same index I can be used for both the strings. Now for counting characters in s, count s of I is equal to 1 plus count s dot get s of I comma 0. The line increases the frequency of the current character in s. So let us break it in part. Okay. Now suppose current character s of I, suppose s is anagram, I is equal to 0, then s of I is a. Now count s dot get s of I comma 0. This asks how many times we have already seen this character. If the character does not exist in the dictionary, return 0. Add 1 plus count s dot get s of I dot 0. This increases the existing frequency by 1. Okay. So I hope this is understood. Now we will code it in lead code as well, means, or we can, I will explain it further. So like consider s is equal to aba. Okay, initially count s is nothing. Now count s of a is equal to 1 plus count s dot get a comma 0. Since a does not exist, count s dot get a comma 0 is equal to 0. Okay, initially, therefore count s of a is equal to 1 plus 0, and now the dictionary become 1. Now this is complete, right? Now we are moving ahead. Count s of b is equal to 1 plus count s dot get b of 0. Since b does not exist, so the current value is 0. So now the dictionary becomes a is equal to 1, b is equal to 1. Correct, right? Now third character a. Now count s of a is equal to 1 plus count s of a comma 0. But this time this was already 1. So 1 plus 1, it will become 2. This is already 1. Therefore 1 plus 1. Therefore 2. Therefore now the dictionary becomes this. Now I hope this is understood. Now the same process we can follow in t as well. Suppose count t of I is equal to 1 plus count t dot get t of I comma 0. This performs the same operation for string t. It stores character from t frequency. For example, t is equal to ba. After processing the entire string, count t is equal to b equal to 1, equal to 2. Okay, I hope this is understood. The order of dictionary entries does not matter. The dictionaries represent the same frequencies. A is equal to 2, b equal to 1, and b equal to 1, a equal to 2. Therefore, since they are different, they are not anagram. Okay, now comparing character frequencies. For C in count S, this loop visits every character stored in count S. For example, count S is this, right? This is for anagram. For the variable C takes the values A and G. The exact order is not important. Now checking whether the frequencies match. If count S of C is not equal to count T dot get C comma 0, this compares frequency of C in S with frequency of C in T. For example, count S A to 2, count T A to 1, C is equal to 1. Then count S of C returns 2 and count T dot get returns 1. The condition becomes if 2 is not equal to 1, this. Okay. So I now hope that the logic is understood. Now we will do this problem. This is like valid anagram. Problem list. Find it. Valid anagram. It is very simple. If length of s is not equal to length of t, return false. Now count t comma count s. Let's do count s. Comma this for I in range. I in range like this. Count t of is equal to 1 plus count t dot get t of I comma 0. Similarly, same thing we can write it for s as well. Count s of I 1 plus count s dot get s of I dot 0. Now we have calculated all the frequencies. Now for C in count s, if count s of C is not equal to count t dot get C comma 0, return false, else return true. So this is what it is. Let us see and run it. What is it? count count t. What is the problem? Oh, this is count t. Now it should be alright. Yes, now it is okay. Now we can submit it. Yes, I think it has been accepted. So yeah, so with this I will stop this video. Thank you very much.